What's up everyone, Shubham here, and this video we are going to explore everything about that there is to an Arduino board. So what you can see in front of you is an Arduino board. It's an Arduino Uno. So as I promised, we will be using an Arduino Uno. If you want, I can definitely create a series on Arduino Nano. And if you still want more, because that should be enough for you to create any sort of project that you would like. But still, if you're like, but I want to use something else, so I'm there. If you want me, I will create on anything else like a Mega or a Leonardo, but it's not required. Getting straight to the point, right? Why do I have an Arduino board kept straight onto your screen and you're just staring at it? A blank image of an Arduino board. So let's have some motion. Good. So we're in video, aren't we? It's amazing. The world has grown to a great extent. But we need to explore this Arduino board. So let's start and compare this board with you. When you are talking about yourself, what should you explain the first? Is it your brain? If that is the thing, or if that is the case, then in case of Arduino, the brain is this processor. So this is a processor that is called as ATmega 328P chip. Now, what is this? This is a huge collection of transistors inside it, through which I connect a serial port, and this is, by the way, a USB type B for buffalo, so that B. And the thing is, you connect the other end to your laptop, that is an Arduino, or rather that is a port type A. And when you connect all of them, well, your Arduino comes to life, like you can just see here. And yeah, in this video, I'm going to destroy this Arduino board in front of you so that I can tell you some preventive measures not to do this on your own. Great sacrifice for YouTube, but anything for you. Okay, so what is this? This is a chip that is what we will be programming. Okay, but there's this other chip that is called as ATmega 16U. What is that for, Shubham? Well, let me tell you, this is a chip that can read binary, that can read whatever you are coding it, but there has to be some sort of a serial connection between you, your computer, the data that you put in, as well as your board. That thing is done by this chip. This chip right in front of you, that is, what it does will be, it takes the command that you put from this, then what is this? It is a USB type B connector. You just connect your stuffs using this, and then what happens is, after the connection, this is a thing that you have which will be like it will transmit, or you can say that it will convert the code that you send over the USB into a language or into a form that this processor can understand, so that, well, it can run. Okay, great, I understood that much. But why is this LED on? Well, that is an on LED as indicated by the letter just that's written right next to it. Then what is this another LED named L? Well, that is a built-in LED that is built inside. Yeah, you guessed it right, on the Arduino board, and it is connected to the pin number 13. Wait, did I just say pin number 13? Yeah, it's pin number 13. But if you're asking to yourself, what the hell is pin number 13 and why, and what are these numbers? Why 11, 10, 6, 5 and 3 have the squiggly thing in front of them, as well as 0 has something pointing towards it, and 0 has something pointing away from it, and 1 has something pointing towards it, as well as there's this thing called as analog in, and then the power. What the hell are those? Well, those are the places that we'll be playing from the very next video. So let me just give you a brief idea of what they are. So these are your actual connectors that are there on the Arduino board. So what you do is, you take a jumper wire right in your hands. Wait a second, I'll just grab one. So you take a jumper wire, which kind of looks like these, and you just poke it inside this, right? So that is why it's really playful. You don't have to really solder anything, you can just plug and play. So it's that simple. So okay, what's next? Well, on this Arduino board, after connecting those things, you need to give in or give out some data. In the initial stages, we will give out some data and then we'll learn how can we take in the data, okay? So, these things are for your input and output. So these are called as IO pins, input output pins. And these ones that you can see here are called as digital pins. Now what is digital and what is analog? Well, digital is like 0 and 1, on or off, two stages. So there are only two possibilities on each of this pin. It can either be on or it can either be off. It can either have a 5-volt supply on it. It can either have a 0 or a 0-volt supply on it. 0-volt supply means no supply on it. Okay, great. But why only 0 and 5? Well, that is the power that the Arduino needs. So when you are connecting this USB not only connects or rather transmits the data and helps you to connect between the Arduino board as well as your computer. It also provides it with the power. Is there some other way through which I can power it? Yes, there's this AC adapter or rather a DC adapter. So you can connect out a battery for this and it will work. You can in the other hands you can just connect it to the AC to DC adapters that there are. A lot of them are there, so just go on buy if you want. Otherwise, this is perfectly fine. Okay. When I'm connecting to the laptop, in most cases I will be getting a 5 volts. But what will happen if I connect it to something which is greater than 5 volts, let's say 20 volts, 25 volts? Won't the Arduino board just blow up because I'm giving it 4 to 5 times more supply? It should, and that's why the creators of Arduino, who are by the way from Italy, as you can see, made in Italy. So those creators added a voltage regulator, a 5-volt voltage regulator for this Arduino board, and it is right this one. So this is a voltage regulator that you can see. Awesome. So this will help me to prevent something. Also, I'm going to tell you that please maintain a limit of the power that you give in, because I'll just tell you a quick story. Once upon a time, I was programming an Arduino board, and what happened is that the project that I was using gave me an output of 48 volts. So what I did was I took that 48 volts and directly plugged it in. Two things happened at the same time. One, the Arduino's voltage regulator blew up, and the second, the ATmega chip started to smoke. So it was smoking. It was enjoying the world to its lowest. So maintain a discipline and don't ever do it, okay? Whew, amazing. But I think I left you with a few things and a few questions in your mind. What are those squiggly things in front of them? Well, those are called as PWM. What is PWM? It stands for pulse width modulation. Oh my goodness, long word, right? What is pulse width modulation? It means that those are the pins wherein you do not just have 0 and 1. You can have somewhere like 0.5 volts or 3 volts or 2.5 volts or something like that. But people do use that pin for mostly output, and they use analog pins for the input. What is analog, by the way? Well, analog pins have a range from 0 to 255. Means that it can give me 255 volts? No. It divides 0 to 5 volts to a scale of 0 to 255. 0 to 255 is a normal scale that you will see in an RGB or in the brightness of a pixel. So in case you connect it to a LED pin, you can control its brightness really accurately. And with that said, what are these 0 and 1 and why do they have a little obscure sort of symbol in front of them? Well, 0 is RX, that means it is a receiver, and TX means a transmitter. And in some images you will see as RXD and TXD, that means for receiver data and the transmitter data. So one is used to transmit the data and one is used to receive the data. But wait, which data am I really receiving or transmitting? Well, welcome to the world of wireless technology. These are used when you are doing some stuffs with the wireless technology that you have. So along, I guess we are out of focus. Just a second. Yeah. So with that said, can I just tell you a few more things? There are two more LEDs, TX and RX. What are those for? Well, TX is to show that that I am really transmitting the data, and RX is when you will be receiving the data and then it will blink or rather light up. And then what is this switch right there which I can press? Yeah, and on pressing it, something happens which is quite similar to when I connected. And exactly that is the work of this pin. This is called as a reset pin. What it does, without a need to cut the power supply and to restart it, you can just press that button. What will that button do is, it will connect your Arduino board to, or rather it will first of all disconnect the power supply and then reconnect it, and that is how you're completely done. You're just fine, you're just done. That's it. And yeah, I just forgot to mention about the oscillator. It's a 16 megahertz oscillator. What does that mean? It oscillates, or rather it refreshes itself 16 million times every second. If I'm not wrong, that is a number. That's 16 megahertz. If you want, you can just convert it. I guess it's 16 million. So it refreshes itself 16 million times, and this board can access, or rather can process 8 bits in each of those processing times. So in 1 second, what is the maximum amount of bits that it can process? It is 8 into 16 million. How much ever so it would be. I guess it will be 6, 8, 48, 8, 98 million. 98 million bits per second. Converted to how many MBs or KBs it might be. And yeah, it has a storage of 32 kilobytes. Don't ever dare store any photo or video on it. It's just not going to support it. Whew. I guess I've already told you a lot about it. And yeah, by the way, these power pins are used to give power. So it's ground, that means negative. Don't worry if you don't know what ground is. I will be explaining it in the next video, because we are already out of time. I am already at 13 minutes, I guess. And it's 5 volts and 3.3 volts. Yeah, you can even have a 3.3 volts output and input out there. Okay, then what are these for? Well, whenever you want to for the very first time, when you want to load an Arduino, you need these pins. You need not worry about this, because under most circumstances you won't be using it. Yeah, make sure that you don't ever touch them with a metal wire, because just see, when I did so, Arduino board didn't quite like it. Yep, Arduino board doesn't like that. So I have a metal thing in my hand. Don't dare do that, because Arduino doesn't like it. There are a few things that Arduino doesn't like, which I'll be telling in the next video. Stay tuned for that. Yeah, that will be the video where I'll tell you what are the things which you should never do with an Arduino, so that you can keep your Arduino safe. For then, keep yourself safe, enjoy your life. Bye.